Hi all, welcome to part 2 of the video lecture on registers, the sequential circuits, right? So in the first part we already seen a basic idea about this register and how we can simply create a single bit of storage, single bit register, say using a D flip-flop, something like that. And for n bit storage we can think of n flip-flops connected, right? So the register is a sequential circuit with the two basic function, the data storage and data movement. So basically it is used for storing data, right? And you can think of the same register for moving the data also, I mean towards right or left, that shift operation I discussed, right? So a register consists of the arrangement of flip-flops and are important in application involving storage and transfer of the data in digital system. Yes, a register consists of an arrangement of flip-flops and are important in application involving the storage and transfer of the data in digital system, right? So mainly for storage, something we already seen inside the CPU, we have this special storage element called the register, right? And it's not used in the main memory and all. Inside CPU, that register is basically made out of the flip-flops, right? And sometimes we want to right shift the data, left shift the data, say in C program and all, you are familiar with that, and for that time you can use it. A register has no specified sequence of states except in very specialized applications. So that is some odd one out, like so by default register is not having any sequence of states like what happened in the counter, where counter is going through some predetermined set of states, right? So register is not having it. So a register in general is used solely for storing and shifting data or moving data, right? So something so entered into it from an external source, right? So from where the data is coming, that is from an external source, and typically it possesses no characteristics internal sequence of states. There is no state for the register, and or a state will be there. We are not interested with that, how the state is changing and all, whether it is going through a predetermined sequence or not. Those things are, we are not interested. We are basically thinking about from an external source data is coming and whether we can store the data into the register or shall we move it right or left or rotate, right? The various types of registers are available in market. So the PIPO register. So what is PIPO? So this is a very simplest form of register, and here this PIPO means parallel in and parallel out. 1 second. Parallel in and parallel out. So that is the expansion of PIPO. So the input is coming in a parallel way and you are taking the output in a parallel way. So typically that is what you can see. How many, see here you 4 flip-flops are being used, right? 4 D flip-flops. So definitely it can store 4 bits. So basically it is a 4-bit PIPO register. That is what is shown in the diagram, okay? And you can see that 4 bits are coming parallelly simultaneously to the register, right? All the D input are coming like that. So let me take an example. Suppose I want to store the information. So typically you can denote D3 as MSB bit, or in any ways a convention D2 D1 D0, and let the bits be like 1101. This is what you want to store, right? So how you will do this? So your D0 is 1, right? And your D1 is 0, D2 is 1, and your D3 is 1. Like that you have to feed the input, right, from the external source. This is the input you want to store inside the register. Now how the storing is happening, that you know, right, in D flip-flop. So whatever be the input, that will come in the output only when the clock is activated, and you know by default this notation says it is edge triggering, especially positive edge triggering, and during the positive transition of the clock signal all the D flip-flop will trigger simultaneously, because clock is applied to everyone and the same clock is applied, right? So all of them trigger simultaneously and they will take that input to the output, because it is D flip-flop. So what is your D? That will be your QN, right? So if this first flip-flop activated and this one will come out simultaneously on the same time. The second one will output 0 and this will output 1 and this will output 1, right? Not outputting, so it is the it's available in your QN, right? So the output flip-flop, okay? So by default, from if somebody is saying from outside, they will see that this 1011 is something kept inside the register. It is trapped inside the register. It's basically 1101 I written in the reverse way. So anyway, so hope you get an idea about it, right? Now the basic PIPO register, this is something I taken from the NBT lecture. You can see that background. See the same figure, but they have using this kind of a notation. This 4 D flip-flop they are using like this, and the inputs are giving like this, right, and the output is also taken like that, and the clock is also there, the positive edge triggered clock. And in addition to that, you can see something called a clear input, right, and I hope you remember this clear and preset input, using which you can directly clear the circuit or set the circuit, right. And here it is active low, right, that bubble wherever it is show active low, means the whenever you are giving that input, I mean, and that clear line, you can see that just like clock, this clear is also applied to everyone, right. And whenever you are giving a 0 to this clear, this will negate it, and that one will come here, something like that. So the clear will be activated when you are giving a 0 to that clear line, right, and that time all of them will clear simultaneously or reset to some initial value, and then some fresh data you can store like that, right. So whatever be the current input, it will reset. If you at any point you want to clear the data that are stored in the system, right, so that is something by default it is there, right. At any point you want to erase the information, something like that, you want to clear it, so that time you can make use of this line. So what is written? When the active clock edge arrives, I mean, again it is a positive edge triggering, right. So active clock means the positive transition of the clock edge. So the input word D1, D2, D3, D4, here they are naming like that. Okay, let it be there. Gets stored in the register and available on the output Q1, Q2, Q3, Q4, and you know why it is so, because we are using D flip flop on the background. Now let's see the symbolic representation of the entire thing. Again, so mostly I refer this NPTEL video. Some of the diagram and points which I find comfortable taken screenshot. So I am okay. I'm acknowledging them for that. So anyway, the symbolic representation, say using vector notation, you can denote like that. So what is it? So this is you have to observe this notation, because you will see it at different point in your textbook everywhere. So whenever this arrows, if I am writing simply, that means a single bit is coming, something like that, a 1 or something. But if I am putting like that and I am writing like 4 or something, some any value, some 8 like that, so what does it mean? Some 8 inputs are coming or 4 inputs are coming, so this means something like this I am feeding in. It can be anything, some 4-bit combination is coming, so that is a meaning. Okay, so that crossing is important, I mean that arrow, then a line across it, something like that. Similarly, here 4 bits are coming out from the circuit, that's the meaning, and this clock is applied, clear is applied. So the entire thing, this bigger notation is actually represented in a very brief way, in a symbolic way. So this kind of a notation is what we call as a vector notation, right. So in the exam also, if they are giving you something like that on the background, they mean this, and that you know. Okay. So by default, D flip flop, those things are not mentioned. Yeah, D is given. Anyway, otherwise also the default implementation of any register is using D only. Now, what about understanding any register in general? What are the things you have to? So we are going to understand different types of register, right? So what are the things you should learn in any register? So for register, we need to understand the following 3 things. First of all, how the flip-flop store a data bit, right? So register is basically made out of flip-flop. So you should have a clear understanding of this flip-flop. Without that, if you're coming here, there is no use. So please watch the previous video where I'm explaining in detail the latches, flip-flops, everything, and how that storing of information actually happens, right? And this D is actually a variation of that SR flip-flop. Hope you remember. And okay, so to understand that whenever I'm giving 1, I'm saying that the output is 1, but how it is so, that is something we already seen. Okay, so I request all of you to go through that previous videos. Now the second thing is the storage capacity of a register. So given any register, what about its storage capacity? And that you already know, basically we have some 8-bit or 16-bit registers we are having, right? Some n-bit register we are having, and on background it is made out of n flip-flop. So always if there are n flip-flop, the storage capacity is n-bit, like that you can determine. So given any register, maybe slight variations are there. So by all those things I'm talking about the default implementation. Okay, and what about the shift capability of the register? Other than storing, we are interested on data movement, right? Shift, how it is shifting data, say from right to left or left to right, or sometimes we will shift from an external source to the register, or from the register to an external source. Inside the register itself, we will move or shift the data right or left or rotate, like that, right? So that about it. That also you have to analyze. Yeah, this is what I was telling, how a flip-flop store a bit. We already seen, right? I request you to go through that. The storage capacity of a register, it is a total number of bits of digital data it can retain or store, and each stage of the flip-flop in each stage. So stage basically here means flip-flop. Okay, so this is something I taken from the NBT lecture. Again, they denote that terminology stage for a flip-flop. Okay, each stage or a flip-flop in a register represents one bit of storage that you know, and therefore the number of stages, how many stages are there, that many flip-flops are there, right? That determines the how many bits the flip-flop can store, that storage capacity of the flip-flop, sorry, register. Now the shift capability of a register. The shift capability of a register permits the movement of the data from stage to stage, I mean from flip-flop to flip-flop within the register or into and out of the register upon application of the clock pulse from an external source, right? Like that, something you know. So these are all the basic movements that are available in any register. So this picture is self-explanatory, right? You can see. So here you can see the main thing is here I can apply only one bit at any time, right? And one bit is coming out of the register if it is a register. But here you know 4 bits are applied simultaneously, right? And 4 bits are coming out simultaneously. And this is something called a parallel input. All the 4 bits are parallelly applied at the same time to the register. But the first thing is what we call as a serial input. I mean, bit by bit we are feeding into the circuit, right? And you know, when one bit is coming, definitely it will be applied at the first flip-flop, and that should be shifted towards right, so that there is a space for the second bit. Now the second bit you can feed. Now this bit will be shifted here and this will be shifted here, so that some space is there for the third bit. Like that you can feed the bits in this register, and one by one you can take out also. And you can see that the input is coming serially and output you are taking serially. And in between the information is shifted left to right, right? So this is a shift right, by default right. And here the information is shifted left, same thing, serial in and serial out, right? Serial in, serial out. So this is serial in, serial out with the left shift. And this is also serial in, serial out, right shift. Okay, right shift register. This is serial in, serial out, left shift register. And here you can see that the input you are applying parallelly, right? So the input is coming parallelly and the output you are taking serially, right? Interesting. So to take the output serially, some shifting is needed on the background. So this is something called a parallel input and serial output. See, parallel in and serial out circuit. Here the input is taken serially, but the output coming serially, and the output is taken parallelly. So this is something called a serial in, parallel out circuit. So whenever that serial data transition is involved, shifting will be there on the background. Without shifting you can't move it right serially one after another, output or input, whatever it is. But here you know this is something interesting. It's the simplest configuration. It's something we already seen, that is parallel in, parallel out PIPO register, right? So here there is no shifting involved actually. So out of this circuit only this parallel in, parallel output is not involving shifting. That is not shown also. All others are having shifting. Data is coming parallelly, going out parallelly, so you don't have to think about that shifting inside the register, right? And here this is something, the same right shift I am having, but the last bit here, the last bit you can take out, or it is simply I mean in you know, the right shift operation and all, the rightmost bit you will not get it right. So once after doing that right shift, you will lose this rightmost bit, right? So it's just going out. But instead of that, you can think of a rotation where whenever you are doing this right shift, the least significant, I mean, instead of discarding it, you can feed it back to the input, I mean MSP position, so that there is a right rotation. The information is moving right in the sense what is this, anti-clockwise, right? So anti-clockwise movement you can see. Similarly here it is left rotation, the information is moving in a clockwise way. So that also you can think of as variation. Okay, yeah, these are all the basic data movement we are expecting. So you can, in any register where this right and basic right and left shift, they are very important in programming and all. Okay, rotation also, everything have its own attention, and the data parallel in, parallel out, all are equally important. Yeah, that about I think you got an idea about simply what is. So this is something we are now one by one we will see, like serial in, SISO, PIPO, like that. Everything we will explore in detail in our. So the actual implementation here, we saw like information is moving right or shifting right, but actually how this shifting is happening, that we will explore in the next lecture onwards. Yeah, thanks for watching.